Okay, here we are combining functions. So, for example, let's say that we have the function f of x equals 2x plus 7 and g of x equals x minus 8. There are lots of ways I can combine these functions. I can add the functions f of x plus g of x. I can subtract the functions. How about g of x minus f of x? I can multiply the functions. G of x times, I'm just going to put a dot there for multiplication, f of x. And then finally, I can divide the functions if I want to. F of x divided by g of x. All right, so I'm just adding, subtracting, multiplying, dividing these functions. I'm using function notation here. Now, the function notation represents a polynomial. F of x is really just 2x plus 7. G of x is really just x minus 8. So really, is there anything different than what we just took a quiz over? No. It's just combining functions. So, let's start with f of x plus g of x. What is that going to equal? Well, how about 2x plus 7 plus x minus 8? All right, and that's a simple, I don't have much room here, but the answer to that would be 3x minus 1. Okay? 1x plus 2x, 2x plus 1x is 3x. Negative 8 plus 7 is negative 1. Very easy. All right. So, g of x minus f of x.
Change the sign behind it.
So, you got x minus 8 minus parentheses 2x plus 7. Like she just said, change the signs after the minus. So, make the minus a plus and then minus minus. And then our final answer will be x minus 2x is negative x. And then negative 8 plus negative 7 is negative 15. So again, nothing different than what we just quizzed over, other than now we're thinking of it, oh, I've got a function over here, a function over here. I want to put those together somehow. Okay, this is how we do it. All right, multiplying functions. So I've got two binomials. G of x is x minus 8 times 2x plus 7. Okay, when we combine these through multiplication, we're using the FOIL method. I'm just going to give you the answer. Okay, because I believe everybody can FOIL. The answer here would be 2x squared. 7x minus 16x is negative 9x. Negative 8 times 7 is negative 56. So there's your solution. Okay? All right, the last one, division. Now, these are the same degree. So if I were to divide these things, I couldn't use long division because it doesn't work out right when they're the same degree. So what it would look like, it would simply be 2x plus 7 over x minus 8. These do not have any common factors. There's nothing here that I can factor out and cancel. Therefore, this is in simplest form. There's nothing else I can do to that. So I can only use that long division process or synthetic division when they're a different degree. The top is 1 degree at least more than the bottom degree. Than the bottom. All right. So that's all it means to combine functions. Got a function over here, got a function over here. It says do some operation to them. You just take whatever those functions are and you combine them. However you need to. Okay, very simple. Now, I told you that was going to be brief. All right. So, Okay, when we deal with composition of functions, I like to think of this as if it were a big Pac-Man swallowing little Pac-Man swallowing littler Pac-Man. You can also think of it like big fish eats littler fish. All right. The what do you call it? The
Indian things going inside each other.
yeah, the dolls. The dolls. What do you call it? The law of the jungle or food chain. Food chain. There it is. Okay, food chain. Big animal eats littler animal eats littler animal. All right, so that's kind of what we're dealing with here. Now, each of these Pac-Man is a function. All right, this is function f, this is function g, this is function h. So I've laid out what these functions represent. Function f is x plus 2. Function g is 2x minus 1. Function h is x squared. Now what we want to do is we want to find the composition of functions, and that means one function is going to swallow another function. Very simple. Big Pac-Man swallows the one smaller than him. Yep. Now, the way that I like to think about this is that when I swallow something, all right, it goes into my stomach, just like it does yours. All right. Hopefully it doesn't go into your lungs when you swallow something, okay? All right, now, so when we swallow this, all right, when Pac-Man swallows littler Pac-Man, the function that he swallows is going into the stomach of the bigger Pac-Man. So when function f swallows function g, it's as if that function g goes into the stomach of f, and x is the stomach. X is always the stomach. So, when I want to find f of g of x, that's how we read this, f of g of x, all right, what I'm going to do is I'm going to write down function f with a big space for where x would be, because that's the stomach. So function f is x plus 2. So I'm going to put parentheses instead of the x, and then plus 2. All right, so that parentheses represents the x, which is the stomach. What goes into the stomach? Function g. What is function g? 2x minus 1. Okay? So we got 2x minus 1 plus 2. Now it's just a basic simplification problem. Okay? So our final answer is 2x plus 1. So f of g of x, is 2x plus 1. That is the result of the composition of these two functions. Where did it come from? Because, see, f of x is x plus 2. All right?
I multiply that.
This is additional. This is not multiplication. This does not mean multiplication. Is that what you're talking about?
Oh, okay, never mind.
All right, so now let's kind of work backwards here. Let's find g of f of x. All right, so if I want to find g of f of x, the big function this time is function g. The function that comes first, we think of that as the big function. That's the one that's swallowing the other function. So function g comes first. What is function g? It is 2x minus 1. I don't know what that is.
So it'll be 2 parentheses.
2x minus 1. So you're going to have 2 parentheses minus 1. Okay? The stuff that's in parentheses is function f. So what is function f? X plus 2. So x plus 2 goes inside the parentheses. All right, now, once I've plugged in, now I just simplify. I'm going to distribute the 2 onto the x and the 2. So this comes out to be 2x plus 4 minus 1, and that simplifies down to
2x plus 3.
2x plus 3. Okay, so the final solution or simplification of the composition g of f of x is 2x plus 3. Now, we can go a step further. We can actually plug in a number for x in order to get an actual number for our answer. So look at this. It says find f of h of 2. Now, there are a couple ways we can go about this. All right? what I like to do is just keep it in the same process that we've been doing, but then where the x is, I need to put a 2. Make sense? All right, so what is function f?
X plus 2.
X plus 2.
So it'll be
So it's going to have
2 plus 2.
big parentheses plus 2. All right? Now what goes in that big parentheses? Function what?
Squared. H.
Function h. Function h is x squared. Instead of, however, putting the x, what do I need to put?
the 2.
2, because inside of function h, we have to plug in the 2. So inside parentheses, it's going to be 2 squared. All right, just a basic simplification problem now. All right, 2 squared is 4, plus 2 is 6. So f of h of 2 is 6. So when I plug in 2 into h, and then h into f, I get 6. All right, so this is composition of functions. Now, there is some other notation that you need to be aware of. All right. Okay. This is the other notation that you need to be aware of. Instead of doing f of g of h, f of g of x, I can do f little circle g, and then the x value comes on the outside. So I've got a 1 in place of the x right here. So this means the composition of functions. So let me just adjust this a little bit. Okay, so f circle g with an x of x means f of g of x. So this is equal to f of g of x. All right. G of f of x, g circle f of x means g of f of x. Okay. So this is the other notation. They mean exactly the same thing. You need to know either way. Sometimes people call this fog and goth. All right? It's not an O. It's just a little circle. All right? It's not a multiplication symbol. It's a circle. All right? It's just a symbol that we use for composition of functions. All right. Now. All right. That was some other stuff.